Recorded is rolling. It is Monday, October 3rd. Remember last time we were together was back on Tuesday, and it's been a few hurricane days. So we're getting back on track here. We're probably going to do this friction lab today. We're going to take today and tomorrow to wrap up the dynamic section. This is this is unit 2 by AP Book, right? So we're talking about forces, Newton's law, and that force causes an acceleration, that sort of thing. Tomorrow I want to do an FR2 with you guys. So today, friction lab, tomorrow, FR2. Also, you guys remember when you were walking out the door back today, okay, let me pause this. All right, and recording is resumed. All right, so we're taking today, tomorrow to finish unit 2, dynamics. You guys remember I handed you the open notes take-home quiz before you walked out the door back a few days ago. So some of you guys already turned in. If you did, awesome. If not, then turn that in tomorrow along with your chapter 4 puzzles. So chapter 4 puzzles and take-home quiz. You'll get guys will turn in by tomorrow. Right. Right. Then we will wrap up dynamics Tuesday, and then Wednesday we're going to start the next session, unit 3, which is going to be okay. Let me prep you guys in advance for what it's going to be. This is going to be a few topics that are put together. So we're going to look at centrifugal force, which involves what's the force of like going around a curve, which we haven't quite addressed yet. We're going to look at universal gravitation, and then we're going to put those two ideas together and do orbits, right? Different textbooks have different philosophies about how to approach these subjects, but AB's gone that way. I've changed my lessons the last few years and gone that way too, so that's what we're going to do. And then Friday is the end of quarter 1, so we're about a quarter way through the school year. All right, so let's take a look at this friction lab. Now, there's 2 parts to this. So there's the left half and the right half. Now, again, I'm trying to get away from giving you guys these very conveniently printed tables and graph spaces, but yeah, try to keep it a pretty good page today. So you guys got this page, right? All right, got metrics here. You guys want this? All right. So what's the 2 perspectives on this friction? Okay. So the left half, the first half looks like this. You guys are gonna have some lab weight. You guys are going to have a spring scale. Actually, the only tool you need for the first half is just a spring scale. Now, the spring scale, guys, one side says newtons, the other side says grams. Which side are you guys reading? Newtons, because newtons measures the force, right? So you're using the spring scale to measure force. Force is measured in newtons. So you guys are using the newtons, right? Okay. You guys have some lab weights on your desk. Oh, ooh, look, I've covered this lab weighted paper. Oh, might want to address that before I go on with anything else. Why would I cover the lab weighted paper? Suppose I'm trying to get what the coefficient of friction between 2 surfaces. Do you think I might want to control what those 2 surfaces are for coefficient of friction? And some of these lab weights are just like this bare metal, and some of them are painted. Do you guys think that between, say, for example, this metal in this paper versus this paint in this paper, think there's probably a different coefficient of friction? Right. Do you think maybe you could control for that by possibly, wrapping them all on paper, for example, or however you do it, right? Maybe you could just use all metal ones, right? Right. That could be another way to control for. Right. So I'm trying to just put kind of control. So this is one solution to that. Right. Now, if I suppose I do this type motion, pull this horizontal and just pull across paper, just drag, just like that. Now, as long as I drag at constant velocity, guys, constant velocity, what's the net force? 0 newtons, right? Right. Now, it turns out it doesn't matter if you pull quickly or slowly, as long as it's constant force. Let's set up a free body diagram for what you just saw, FBD, free body diagram. Okay. What's one force on that lab weight? How about weight? Let's start with, gravitational force, weight. I'll call that mg for weight, right? What's another force? The normal force, F sub n, which is equivalent magnitude. I could say equals mg, couldn't I? As long as you pull horizontally, that'll be true. You have to pull up on an angle. That was one of your quiz questions that throws that out of whack. But I covered that back last day I saw you guys. Okay. Then I was pulling with some force. I could call it F sub pull or F sub applied, like an applied force. Right. And then if it was at constant velocity, there had to have been a force balancing that out, which would have been what force? Friction force. Right. Now, guys, coefficient of kinetic friction is the ratio of which 2 of those forces? Bam! Friction force over normal force, right? So that one compared to that one, right? And you have a direct measurement for the pulling force because you can just read it straight off the scale. And the weight, hey, do you think if you just hang it in the air, that would pretty much represent the weight which again, would be the normal force. Guys, pop, pop, pop. See how all the puzzle pieces pop in place, and you could solve for the coefficient of friction that way, right? Oh, I should have been more explicit with that question. That is what you guys are trying to figure out with this lab, is what is the coefficient of friction between two surfaces? Okay, is that right? That's the question. Right. Oh, I'm gonna have you guys do a 5-part write-up, and that's the first part. Is what was the question? So everybody's trying to answer the question: what's the coefficient of friction between blah 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 surfaces, right? Right. Now, here's the thing with the write-up. I'll give you guys an option. You can either do the write-up for what I just showed you, or you can do the write-up for the next one. Now, the next setup, part 2, right, the right half of the paper. Oh, you need a different measuring tool. All you need is a protractor. Don't have a word. Borrow this. Thank you. All right, so for demonstration, this is your protractor, right? Right. All you need is a protractor. Now, do you think you could get the coefficient? Here, what if you do this? What if you set your lab weight on your table, just on your desk, or whatever surface you're comparing, right? And start lifting. And at some point, it's going to break friction and slide down at a constant velocity. Hey guys, if it slides down at constant velocity, that would also be equilibrium, wouldn't it? Right? And do you think that whatever the coefficient of friction is and whatever angle it is that slides down at constant velocity, if you knew one, you could in principle determine the other, right? So all you need for part 2 is a protractor. You don't need any other tools. Let's set up the free body diagram for this, FBD. Maybe this one's a little bit more involved, right, but I think you guys can figure this out. Right, so this thing has a weight, mg. Okay. You know what I should have done is split this into, I need to introduce a Cartesian system that runs parallel to the surface and perpendicular to the surface, right? You're going to do that whenever you see a situation like this, right? And that weight, I'm going to split into these dashed components. Okay, well, the weight is partially pushing the block into the surface. It's partly pulling the block along the surface, right? Theta, theta, same theta. So here's your mg cosine theta. Here's your mg sine theta. You guys remember this? Okay. Oh, I bet there's a normal force holding this in place. F sub n. I bet you guys can see what that's going to be equivalent to. And if it's if I just stop there, that actually would be exactly free body diagram for your Hot Wheels lab where those cars were rolled down the incline, which would be an accelerating situation. But if it's sliding down at constant velocity, that's because there's a friction force that is exactly balancing out this mg sine theta, isn't it? Friction force, right? Hey, do you think you could still sort of use this expression here to solve for coefficient of friction? Except it's going to be maybe a couple extra steps involved in between. All right, so here's what we do. Get some of these, Maybe you won't finish the whole table. Try to get at least 3 of these, make a graph, right? Then pick your favorite one and do this 5-part write-up. And then, last about 10 minutes of class, I'm going to pull out the scoring rubric and have you guys score yourselves. Okay? All right, you guys good? All right, so I'm going to pause this recording and then walk around and help you guys out.